Now there are different ways of polarizing the light. Okay, one of them is polarization by scattering. See, what happens here is, so in atmosphere, usually this happens naturally in atmosphere. So a particle which is almost comparable to the wavelength of light, let's say, comes directly in front of a ray of light. Okay, so basically remember, the ray of light which is coming from the sun, it's an unpolarized light. Okay, so an unpolarized light comes and hits the particle. Now if it hits the particle at a certain angle, then the light will scatter. This scattered light will be plane polarized light. Okay, so this is polarization by scattering. Now what we have to notice is, if the unpolarized light is coming in the x-axis, alright, then the polarized light, that is the plane polarized light, will move in the y-axis and z-axis. Okay, so that means the plane polarized light is perpendicular to the unpolarized light plane. Okay, this is polarization by scattering. The second one, or the second method, is polarization by reflection. Okay, now this is quite an important part, because see, when we are looking at polarization by reflection, so when we talk about reflection, first thing that comes to our mind is a mirror, correct? But in this case, we are not looking at a mirror. We are looking at a normal glass slab or some other material where refraction can happen. See, let me tell you one thing. Whenever refraction happens, a part of the light will also get reflected and a part of the light will also get absorbed. Okay, so it won't be 100% refraction. Okay, the same thing goes with reflection also, actually speaking. Okay, so here what happens is, we are looking at polarization by reflection, correct? So we keep, let's say we keep a glass slab, imagine a glass slab of refractive index mu. Okay, so we incident the ray of light. Now the ray of light has to be incidented at a particular angle, what we call as a polarizing angle. Okay, then it undergoes refraction and reflection. So the reflected light will be plane polarized light. Okay, so we need to define this now, correct? The angle of incidence at which, when ordinary light is incidented on transparent refracting medium, the reflected light becomes maximum rich in plane polarized light, is called polarizing angle. Okay, so I'll repeat the last part again. So what we are doing is, we are incidenting the light. The reflected light becomes maximum rich in plane polarized light. This angle is what we call as polarizing angle. So if you look at the figure, see the figure, you have been seeing that the reflected light is the polarizing angle, polarized light, correct? And the angle of incidence is the polarizing angle. Okay, so here what exactly happens is, whatever the transparent medium we have, the transparent medium, so the refraction happens, the refracted ray will be an unpolarized light, but the reflected ray of light, that becomes plane polarized light. Okay, so this phenomenon is nothing but polarization by reflection. Okay, so what should be the refractive index of the material for polarization to happen? Then what should be the angle? Angle we got to know, it has to be the polarizing angle. But is it constant for every material medium? No, obviously not, right? So how are these two related? So next video you will see how these two are related. We have a law based on this.